Okay. Good day. Before we proceed to our discussion, let me introduce myself first. I'm Jeruel Balyeres, and I am a BSBA Management Information System student, and I am currently located here in Riyadh, Saudi Arabia. Okay, so for this presentation, um, we will be discussing about my chosen topics, which are the object-oriented programming, and it's all about pointers and references 1 and 2. Okay, so for the first slide, we have object-oriented programming. So it says here that it is a programming paradigm which is centered in the use of objects. Okay, so objects refer to as representations of tangible and intangible materials that possess some level of information. Okay, so these objects can be anything from day-to-day materials that we are using for classification, like the Congress. Okay, so the only thing that limits them is the information that they should possess for us to implement afterwards through programming. Okay. Next, we have the advent of object-oriented programming. So the practice of object-oriented programming came as early as the year 1967. Okay, so in that year, a programming language, Simula, used features which we regard now as the fundamentals of object-oriented programming. Okay, so when we say Simula, it is a programming language which specializes on simulations. Okay, so next we have the Dynabook. So Dynabook was the first personal computer that was created using object-oriented programming. Okay, so Simula is a programming language which specializes on simulations, as we have read in this presentation. Okay, so Dynabook was the first personal computer that was created using object-oriented programming, and Smalltalk was the object-oriented programming language built specifically for Dynabook. And since then, object-oriented programming became popular. So this gave birth to C++ as a programming language that supports object-oriented programming. Next, we have the subsets of object-oriented programming. We have the prototype-based and the class-based. Okay, so for prototype-based, this is a subset of object-oriented programming which focuses on reusability and reusability of the objects in terms of extending initial state further defined state. So in this design, prototype is created by developer, which will be copied and modified during runtime to to represent the final state of the object it represents. Okay. Next, for the class-based, this one is focuses on abstract representation of the objects. So it means there is no initial data present in the object definition. Okay, so in this design, objects may share the same properties and method. I'm sorry for that. Next, we have the principles in object-oriented programming. We have number 1, encapsulation. Next, we have abstraction, inheritance, and polymorphism. Okay, so we will discuss this one by one in the next presentation. In the next slide, the following slide. Okay, first we have the encapsulation. Okay, so it says here that to hide the internal workings of your applications. Okay, so this is used to hide the internal workings of your application. Okay, so this ensures that only necessary methods and properties are presented outside of the current class. Okay, so this principle is initially enabled using scopes which we have in C++, namely the public, private, and the protected. Okay. Next, we have accessors and mutators. So this is in addition to scopes that I have mentioned a while ago. We have accessors and mutators, which limits the actions done in properties. Okay, so by extension that include methods. Okay, so for accessors, we have this is a method within the class that enables the retrieval of values hidden by scope. Okay, and the mutators is a method within a class that enables the assignment of values to our properties hidden by the scope. Okay, next we have the abstraction. So it is the generalization of classes and types to emphasize their functionality and interfaces over their implementation and details. Okay, so this principle works together with encapsulation. Okay, so the first one that I have mentioned. Okay, so since both are focusing in making the internal workings of the classes hidden from outside of the class. Okay, so one of the way to implement abstraction is using the scope. Okay, so when we say scope, it is a limit, it limits the way any other classes and functions interact with the properties and methods of the class. Okay, next we have the inheritance. Okay, so for inheritance, it means to extend the features and functionalities of existing classes and interfaces. Okay, so when we say interface is a class in C++ which has methods that are virtual in nature. Okay, and when we say virtual, it means that the method is not implemented inside of the class. Okay, so in this principle, there is a prerequisite of at least one existing class or interface. Okay, so as I have mentioned about interface, it is a class in C++ which has methods that are virtual in nature. Okay, so last one, we have the polymorphism, which deals with different variations of the same method, uses the same function name, and only differ the combination of data types used in their parameters. Okay, so polymorphism. Okay, so there are two types of polymorphism, the overriding and the overloading. So overriding occurs during compile time and or common structure of polymorphism, while overloading, on the other hand, occurs during runtime. Okay, so in this form of polymorphism, the functions are given different parameters but share the same function name. Okay, so that's the difference between overriding and overloading. Okay, next. So that would be the end of our first topic. Now let's proceed to our second topic, which is the it's all about pointers and references 1 and 2. Okay, so there you go. We have introduction to low-level C++. Okay, so programming languages categorization in terms of complexity. We have high-level, low-level, and mid-level. Okay, so for high-level programming languages, so these are programming languages that exhibits the strongest abstraction of its programming schema. Okay, so this is also the easiest category of programming languages to work with. Okay, so it enables developer to focus on the logic of the application they are developing. So it also limits the control of the developer over the operating system. Next, we have the low-level programming languages. Okay, so for the low-level programming languages, this exhibits the weakest abstraction of all the programming languages, aside from machine languages themselves. Okay, so this is the hardest to manage of all the three categories of programming languages. Okay, so it says here that it enables the developer to get into the detail of how they like their logic to be implemented. Okay, so it also lets the developer explore the world of embedded systems and give them access to even smallest component in the environment. Okay, next for the mid-level programming languages. Wait a second. Okay, mid-level programming languages. So this exhibits strong abstraction and mid-range access to the memory and operating system. Okay, so mid-level programming languages are the go-in-between of the other programming languages. Okay, so this showcase user-friendly implementation and structures. Next, we have introduction to pointer and references. So first, we have the pointer, so special variables in C++ that points to a sector in the memory. And then we have the references, which are the special variables that stores the address of a variable. Okay, so the main difference of these two is that the address stays permanent in references, whereas pointers can change the variable where they point to. Okay, so next we have the declaration. Okay, so uh, in the previous slides, we talked about using pointers and references in variables. Okay, now we will go in depth with how a pointer variable and the reference variable work. Okay, so we'll be discussing the differences between variables, pointers, and references when undergone through a cycle operations commonly conducted throughout an application lifecycle. Okay, so we will be enumerating the behaviors of variables, pointers, and references. So in declaration, the variables here the data type followed by the variable name. Okay, so variable name may start with several underscores but must never start with numerical value. Okay, so in pointers in declaration uses asterisk operand prior to variable to signify that we are declaring a pointer and not a variable. Okay, so next is for references, it uses ampersand operand prior to the variable name to signify that we are declaring a reference and nothing else. Okay, next, we covered the effects of the data types for these three. Okay, so it says here that data type is variable, pointers and references are all data type agnostic. Okay, so here in data type, variables, pointers, and references are all data type agnostic. Okay. Okay, so next is for initialization. The pace, this is the pace wherein a variable, pointers, and references are assigned their default or initial value. Okay, so here, variables and pointers behave the same. Okay, so reference only differs from the two. Next, here in value stored, variable stored the actual value it is supposed to store. Okay, so the value stored within the pointers and references are the address of the variables they are initialized with. Okay, so variables behave differently in this case, while pointers and references behave similarly in value stored. Next, we have the variable reassignment. A variable reassignment occurs when a variable is being assigned to a pointer or reference after the initialization stage. Okay, pointers undergo variable reassignment while variables and references do not undergo reassignment. Okay, so it speaks for itself. Okay, next we have the assigning a variable. Okay, so assigning a value, or it is also called as assigning a value. Okay, so assigning a variable means a variable is used in the assignment operand. Okay, so here variables are being assigned and variable takes a copy of the value of the second variable and stores it to the first variable. Okay, so this way the value of the second variable is preserved while the first variable disregards. Okay, so its value changes it with the value of the second variable. So different scenario occurs to pointers and references. Okay, so both of them copies the value of the variable being assigned and stores them to the variable they point to. Okay, so next we have assigning a value. So assigning a value means a constant is being used in the assignment operand because the actual value is being stored. Okay, so here variable directly stores the value to the memory they are allocated. Okay, so they do not copy it anymore and simply store them without undergoing various operations aside from data type checks. Okay, same goes to pointers and reference. They check the data type of the value being assigned and the value is being redirected to the address and store it the said value to the address. So this will update the value stored in the variable they point to and overrides an existing value. Okay, next we have retrieving the value using standard method. Okay, so this is a conventional method to retrieve the value. So it does not use any other symbols aside from variable name itself. Okay, so in this case, variable returns a copy of the value it currently holds in its allocated memory and no data is returned during the retrieval. Okay, so pointers on the other hand pointers behave differently from variables because they return the address of the variable it currently points to. Okay, so this address is the actual value stored within the pointer. Okay, and for reference, it behave half variable and half pointer when retrieving the value using the standard method. So like variables, it returns the value of the variable it points to. Okay. Next, we have the retrieving value using the dereferencing operator. Okay, so retrieving the value using the asterisk unary operator. So it stands for the referencing operator. Okay, so this operator returns the value of the variable a pointer is pointing to. Okay, so this is only applicable for pointers. Okay, so it retrieves the value stored in the address at the pointer. So while on the other hand, variables and references do not support the use of the referencing operator. Okay, so it would result to errors during compile time if being implemented or attempted. Okay. Next, we have the retrieving the value using the address of the operator. So this is the ampersand or ampersand unary operator. Okay, so this stands for the address of the operator. So this operator retrieves the address of something in the memory. Okay, so using the address of operator in variables, variable returns the address of the variable. Okay, so the size of the allocated space depends on the data type of the variable. So now, using reference, it will return the address of the variable it points to. Okay, so while in pointers, it will return the address of the pointer. Okay, so I hope you get my point. Next, we have the function, pointers, and references. Okay, so it is possible to use pointers and reference in functions. Okay, particularly in the return type and parameters, mainly because a function is just a separate code block that contains its own set of statements which are focused on replicability. Okay, so to implement pointers, reference, in functions, we will first invoke some of our parameters to be a pointer. So the process is like how we declare variables as pointers. Okay, so we will simply append the referencing operator or the asterisk sign or the asterisk asterisk sign to our parameter name. Okay. Okay. So that I think that's the last part of our presentation. Okay, so that would be the end of our presentation, and the part 2 of this course project will be on separate file. Thank you for listening. Thank you for your time and for listening here in my presentation. Have a nice day.